In this video, we're going to be looking at some examples of using the circumcenter and its properties. So for number one, I'll use a diagram to answer the following questions. So I see here, I have this triangle JKL, and I see I have this point P in the middle. I see that I do have perpendicular bisectors that are all intersecting at this point P. And I know that because first, they are all intersecting at this right angle on the side of my triangle. And I see that they're all exactly in the middle of the sides. And I see that from these congruent tick marks. And so that means I know that P is the circumcenter. And so for part A, it says to name the perpendicular bisectors. And so I see that's going to be MP, and again, perpendicular bisector because it's intersecting at a right angle, and it's intersecting exactly in the middle. So I have all of my blue lines are my perpendicular bisectors. So I have MP, NP, and OP. And we want to name this circumcenter. We already did that. We figured that out from this picture. And so that's going to be point P. And then we want to list all the congruent segments. So first, it's already marked here some congruent segments from these tick marks. So I know that JM is equal to ML. JN is equal to NK. And LO is equal to OK. But then we also have some other segments that we know are equal from our circumcenter theorem, and that was that all those points that connect to our vertices from the circumcenter are also congruent. So that means in our example here, that's going to be these red lines that are equal to each other. And so I have that JP is equal to KP, which is also equal to LP. Okay, so now let's actually apply these definitions and theorems into finding some measurements in a triangle. So for number two, I'm given that U is the circumcenter of triangle GHI, and I want to find each measure. So again, remembering what it means that's the circumcenter, I know that these blue lines are all perpendicular bisectors. So for instance, I know that GX is congruent to XH, HY is congruent to YI, and GZ is congruent to ZI. And then another thing I know is that the circumcenter is equidistant from all the vertices of the triangle. And so that means that GU is congruent to HU, which is congruent to IU. So now let's go ahead and actually find some of these measurements. So first I want to find UH. So UH is this red segment right here. Well, I know that UH is congruent to the other two of these red lines. And I know that UG is equal to 14, so that means that UH is also going to equal to 14. Next, I want to find GZ. So I see GZ is this segment here. Well, I know this segment is congruent to ZI, and ZI is equal to 13, so that means that GZ is also equal to 13. Next, I want to find XH. So XH is this segment here. I know it's congruent to XG, however, I don't know the length of XG. But I do know that the entire length of GH is equal to 20. And so to find XH, I just need to divide 20 by 2. And so I get 10. Next, I want to find YI. Well, I know that YI is congruent to YH. And since YH is equal to 8, that means that YI is also equal to 8. Then next I want to find UY. That was a typo. We're not actually going to find EY. And then lastly, we're going to find GI. So GI is this entire segment. I know that ZI is 13, so that means that GZ is also 13. And so to find the length of all of GI, I just need to do 2 times 13. And I get 26. Okay, go ahead and pause the video. I want you to try and work through number 3 on your own. When you think you have it, go ahead and press play. So the answers you should have gotten were the following: 7.5, 11, 15, 6, 9, and 11.